Let's learn about Newton's second law. It states the acceleration of an object depends on its mass and the force acting on it. Acceleration is directly proportional to the force and inversely proportional to its mass. F net is equal to ma is the equation. What is acceleration directly proportional to the force and inversely proportional to its mass mean? We can derive that from the equation of Newton's second law. Our equation is F net, or we can just write F equals ma. Dividing by m on both sides, we get A is equal to F over m. So that means when the force acted on the object, when this goes up, A will also go up. The acceleration will increase if force increases. If mass goes up, it makes the fraction smaller. So when mass increases, the acceleration of the object decreases. So that's why it's called inversely proportional. So force is directly proportional to the acceleration and mass is inversely proportional. Okay, now let's see what acceleration actually means. So acceleration is the change of velocity per second. So the equation for acceleration is A is equal to Vf minus Vi, so V final, that's what V sub f means, minus V sub I, V initial, divided by T, the change in time, and we can also write that as acceleration is the change in time over the change in velocity over the change in time. Let's explain this with a ball, that's an object that's moving. It starts with a velocity of 20 meters per second, and after 2 seconds, 2 seconds pass by, and after 2 seconds it has a velocity of 30 meters per second. What is the acceleration? So we can plug it into our formula over here. V final minus V initial, what's the final velocity, is 30, minus the initial velocity is 20, over the change in time, which is 2. We get 10 over 2, which is equal to 5 meters per second squared. Acceleration is measured in meters per second squared because velocity is measured in meters per second and time is measured per second. So divide those two, we get meters over second squared. That is what acceleration means. Now that we know what the law actually means and what is acceleration, we can work through some problems using Newton's second law equation. So let's start with, we have an object on a surface. The object has a mass of 10 kg, 10 kilograms, and a force is applied to it, and the object produces an acceleration of 6 meters per second squared. What is the force that's acting on the body? So we can use our formula, Newton's formula equation. F is equal to ma. Plug in what we know. We need to find the force. We see that the object's mass is 10 and it has an acceleration of 6 meters per second squared, and we get 60 newtons. Force is measured in newtons. So that is the force that's acting. 60 newtons. That's what the force is acting. Now, let's try a new example. We have a body of mass a body of mass x and 20 Newton force acts on it. So a force of 20 newtons, a force acts on it, and it generates an acceleration of 10 meters per second squared. What is the mass of the body or object? So we can use Newton's formula again, but this time we don't know what the mass is and we know everything else. So 20 newtons of force is equal to the mass of the object times its acceleration. Here, let me start with the equation. Okay, 20 newtons of force, we know, is equal to the mass of the object, it's x, and it produces an acceleration of 10 meters per second squared. So x is equal to 2 kilograms. That's the object's mass. Now let's try one last example. We have a body of mass 10 kilograms and it has 10 newtons of force. It's acted on by 10 newtons of force. So 10 newtons. And we need to find the acceleration that the object produces. And we're going to denote that as x meters per second squared. So once again, we use Newton's formula, F is equal to ma. We know what F is, the force is. We know it's 10 newtons, and we know what the mass of the object is. It's 10 kilograms, and the acceleration is x. Divide by 10 on both sides. X is equal to 1 meters per second squared. 1 meter per second squared. So that is what Newton's second law is. It relates the force of an object, the acceleration of an object, to the force acting on it and its mass. That's Newton's second law. Thank you.